Okay, so now let's move on to the homework assignment that I handed out in class today. You received a paper that looks like this, with a part on the back that should look like this. So the directions say forces can be balanced or unbalanced. Use the terms in the word box to label the diagrams. One word is used twice. Okay, so what I'm interested in is getting an appreciation of um, your understanding of forces as they relate to most any type of physical application. In this case, I decided to give you a diagram with a book on a desk. In picture 1, the book is sitting on the table, and the table is, well, I don't want to say it because I'll give it away, but it's the book is sitting on the table, and in picture 2, the book is falling off the table. All right. So let's do the first picture together. Kind of a little bonus for watching my video. Okay, so it starts off by saying that forces are blank. Well, the book is sitting on the table. It's not falling off, right? Out of the vocabulary in the word bank, what would be the best choice? Forces are gravity, forces are table, forces are rest, forces are balanced, unbalanced, or accelerate. Well, the book is sitting there, right? It's balanced. So for number 1, forces are balanced. Number 2, blank pushes down at 9.8 meters per second. That's important. What's the force we've been talking about that pulls down? Gravity. Blank pushes up. So let's ask a question. If gravity is pulling down at 9.8 meters per second, what has to be pushing the book back up at 9.8 meters per second? The force at the table, right? Because if the book was sitting on the desk, okay, and force of gravity is a number, but the force of the table is not as big of a number, what would happen is this book would come crashing through the table and would continue to sink into the ground. Everything on Earth as we know it would sink into the ground and probably go into the core of the Earth if the force was not equal to what gravity was. So the book remains at blank. The book remains at rest. Okay? So do this. Get it into me by, let's make it Friday. Such a nice guy. I give you so much extra time to do your homework. So Friday. Same thing for this back. Okay? Let's move on to this. So in your book, you learned that velocity is the speed of a moving object in a particular direction. The diagram below illustrates the velocity of a spacecraft after it has been launched. Orbital velocity is the velocity required to enter an orbit around Earth. Escape velocity is the velocity required to overcome Earth's gravity and travel into space. Use this illustration to answer the questions that follow. So you have a little diagram here that says suborbital velocity less than 8 kilometers a second, orbital velocity about 8 kilometers a second, and escape velocity about 11 kilometers a second. Now, for those of you who might have studied Earth and space science to some extent in your other classes, you might have talked a little bit about something called escape velocity. And simply what that means is there is a velocity required to break free of a planetary orbit. Remember, we have gravity pulling down on us at 9.8 meters per second. That is an incredibly strong force, and you need a certain speed in order to break that barrier and get away from the planet's grasp, essentially, is what that's saying. So the suborbital velocity and the orbital velocity are speeds where orbital means that the shuttle flies around and around and around the Earth at a speed that is constant, that is, it is such that it is just canceling the force of gravity. Gravity cannot pull it in, but at the same time, the shuttle cannot pull away. And suborbital velocity then would mean that the shuttle is very slowly getting pulled back to the Earth. All right. So number 1 asks, can a spacecraft traveling at 5 kilometers a second achieve orbit around the Earth? Explain your answer. Well, let's think about this. Number 1, it asks, can we achieve orbit? Well, what does it say about orbital velocity? We're just going to abbreviate this OV equals 8 kilometers per second. So at 5 kilometers, can it achieve orbit around the Earth? Well, we need it to be greater than or equal to 8 kilometers a second. Do you understand why that is? Well, let me explain if I can. Okay. The important thing is to understand the number. All right. The reason is largely found in the number. For this purpose, let's just think of the number. Okay. It's asking at 5 kilometers, can it do it? So 5 is less than 8. Therefore, no. And an answer you could put down to explain that is no, because orbital velocity needs to be about 8 kilometers a second. See if you can finish number 2, 3, and 4 on your own. And again, I will be more than happy to answer any questions you have regarding those items. But do attempt to do that, and it will be assessed for a grade. Thank you very much for watching, and see you on the 26th.